Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on minimum window substring. This is one of the most frequently asked problem in coding interviews. So let's just quickly jump into the problem statement, understand it, and start coding. Start solving. Okay, last time we solved the kth smallest element in BST. We'll mark it checked. You can find it in the list. And with this, we have finished all the easy and medium level coding questions, and we are starting with hard, level hard, difficulty hard. Okay, let's start with the minimum window substring. Okay, so it is going to be hard. I'm excited. Given two strings s and t of length m and n respectively, return the minimum window substring of s such that every character in t, including duplicates, is included in the window. If there is no such substring, return the empty string. The test cases will be generated such that the answer is unique. Okay, great. Now, we have the string s, a, d, o, b, and t, a, b, c. Output is b, a, and c. If we see b, a, and c is here, it covers all the characters from this string, that is a, b, c, right? Actually, we could have taken this answer, which is A, then we covered B and then C. But this length is much bigger. This is 1, 2, 3, 4, 5, 6, and this length is 4. So this is a smaller length, and we have to find the minimum window of substring. So minimum window, which covers all the letters from the string T. Okay. Now, the problem statement is very clear. I would suggest take a minute and think of an approach that you would take before I start coding. Okay, ready? Now if you observe few things, in the second example the characters are small. In the first one the characters are capital. So that means the characters can either be small or capital. One more thing is, once we have found the solution, like we are trying to find out all the characters from string t from the string s. So we found A, then we found B, we found C. We have found the solution at this point in time. And this could be the ultimate solution as well, but we cannot be sure. So we need to keep track that, okay, this is going to be our minimum length. Plus we have to continuously look for the other solution. If we find a length smaller than this one, then we'll update our minimum length, right? One more thing is, so we will only stop once we have traversed the complete string. Secondly, how we can solve this is, let's say we start from A. We found a character from ABC, we'll mark, okay, A has been already taken. Then we encounter B, okay, B is found, C is found. So all the characters from ABC have been found. We'll record this, we'll know the minimum length, we'll know the window, okay. Now, one by one, we'll start removing characters from the left side. So we need to keep count in the left and right pointers, right? Now it is D, O, B, E, C. Now is D part of this substring? No, right? D is not required. Will not take D, will not take O. We are at B, E, C. But still, this does not form our solution, because required length of characters coming from ABC is 3, and here we only have 2 characters. That is B and C. So we'll look for A. Okay. So we go B, E, C, we go till A. We found a solution, but this length is bigger than the last length that we have found, right? This is 1, 2, 3, 4, 5, 6, 7, 8. We have found a solution in 6. So we'll start removing B from this end. We remove B, this character B. Again, we are at this solution, but this does not contain all the characters from ABC. It only contains A and, it does contain A, B, C. So it does contain, but E is not required, so we'll remove E. Now this is one of our solution. Again, the length is 1, 2, 3, 4, 5, 6. But this is same that we have already found a window of 6 length, right? So we'll keep moving forward. We'll remove C from here. Now this is our window, but we do not have the third character. We only have A and B. We'll remove all the unnecessary character from the left side. O, D, E will get removed. B and A are here. We'll move forward. We go B, A, N, and then B, A, N, C. Now again, at this point in time, we found all the 3 characters A, B, C in our window. And this length is 1, 2, 3, 4, which is smaller than the previous length. So we'll update that length, right? Now we want to incorporate all these things before we have to understand all these things before we start coding. Okay, with all this thing in mind, let's start with our solution. Okay, so what do we need? We need a map or an array to store the frequency of the characters, because as they mentioned there can be repetitions, right? So we want to store the frequency of these characters. Generally how we do that is we create an array of size 26 and store in the form of their ASCII values. But in this case the letters can be in capital or in smaller format. So we'll take the complete array of 128 since the ASCII values go from 0 to 127. So we'll say array to RESENT represent the frequency of CHAs RACTRS characters in the current window. Now, which string characters do we want to record in this one? We want to record T, because we are going to search T, that is this one, in S, right? We'll create int char count window is equal to new int of size 128. Okay, now we'll initialize the frequency array with the characters from our second string, that is string 2. So we can say, okay, initialize the frequency array with characters from string T. Okay, so for character C from T dot to character array, and we'll increase the frequency. So char count window of C plus plus. Okay, now we have in this array we have recorded the frequency of all the characters from string T. So this part is done. Now we need variables, right? We need pointers on the left and on the right, plus we want to know what is the required length that we want to cover. Plus when we are removing characters, like in this case when we had this solution and we removed A, we want to mark that the required length of character, which was 3, has now been reduced because we have removed one of the required character A. So we need a variable for that as well. So we'll say variables to track the window boundaries, boundaries and character frequencies. Okay, so we can say int left is equal to 0. Similarly, int right is equal to 0, since we are going to start from the 0th index. Int required characters is equal to T dot length, right? That is this length, plus int formed characters, that is the overall characters that we have found, formed characters will be 0. So we have found these characters in one of the windows. Okay, now what else do we need? We need more variables. We need more variables to actually keep count of the minimum length. Like earlier we had achieved a minimum length of 6, so that next time we can compare that it is smaller than our previous minimum length. And similarly for this one we would again need separate indices for left and right to return it as a substring of S. So we need a minimum left and a minimum right as well. So we can say variables to track the minimum window. Okay, so int min length is equal to, we'll initialize it with the maximum value, integer dot max value, and then int min left is equal to 0 in the beginning. Similarly, int min right is equal to 0 in the beginning. Now we'll start the traversal. Okay, while right is less than s dot length length. so that one by one we'll start traversing through all the characters. Okay. Okay, so we are going to expand the window towards the right side. We are starting from here, we'll keep increasing our right and we'll keep expanding our window till we have formed all the characters from this required string, right? So we can say expand the window to the right. So character C right, first character will be s dot caret right. Okay, since we found one character C right, we don't know which character it is, right? So in our character frequency array we'll reduce its frequency. So we can say char count window or right index, not right index, C right minus. Okay, so we'll reduce the frequency of A, okay, from our character count window. Okay, now how do we know if the current character, this character, is actually part of the character that we need from this? We'll simply check for its frequency. If its frequency is greater than or equal to 0, then yes, we have found one of the characters, right? So we will check, we can say check if the current character contributes to the required characters. So if char count window C right is greater than equal to 0. Okay, so we can say we found at least one character, so formed characters length will get incremented. Now what else do we need? So we found the characters and one of the character has been found. We have increased the length. We should increment our right side pointer, so we can say right plus plus. But then we also need to check if so that is also the breaking condition for this while loop. We also need to check if we have found the solution in this overall running of the code, if we have already formed a solution, if we have found the solution, right? So we'll check it inside this loop only. So that will be to contract the window. Okay, so that will happen when we found the character A, that is part of the character window. We'll increase the formed character length, so length has been increased to 1. Similarly, we go through D, it will not increase the value. O, B, E, C, at this point in time formed character length will reach 3, so we need to check for it, right? So we'll start contract the window from the left. So we can say how will we contract it? Okay, while formed characters is equal to required character length. Required characters, what is a required characters? Okay, variable name is required characters. Okay, so whenever we have found all the characters required in the required length, that means this is the time that now we should contract the window from the left hand side, as long as the formed characters are part of the window. Okay, so while, and we'll update our minimum window as well. So we'll say update the minimum window if smaller has been found. So if right minus left plus 1 is less than min length. So at this point right is at C, that is 0, 1, 2, 3, 4, 5. 5 minus 0, 5 plus 1, 6 is smaller than our min length. Min length is initialized with max value, so yes, that is true. So when this happens, we'll update our min length. So or we'll update our min length. Min length is equal to, it will be right minus left plus 1. Okay, And similarly we'll update our min left and min right as well. So min left is equal to left, min right is equal to right, but plus 1, because we'll be reducing the substring out of it, and when we are doing the substring operation, the right side value is not picked up, right? Okay, now we are going to contract our window. Okay, this will be to or contract the window again. We'll say contract the window from the left. Okay, so we'll check char c left is equal to s dot caret left. So we'll get a in this, right? For this we'll reduce its frequency or increase its frequency. Since we are removing a, will increase its frequency. So char count window of c left plus plus. Now we are going to check if the current character no longer contributes to the required characters, right? So we'll say check if the current character no longer contributes to the required solution. Let's write characters only, characters. I want to write solution, right? Required characters. Okay, like in this case we checked, and if it was part of the solution we increased the formed characters length. If it is not part of the, if the removed character was part of the solution, like a in this case was part of the solution, so we'll remove the formed characters length, so that we'll know that in this current window after removing a we have one less character from the required length, right? So we'll check if char count window c left is greater than 0. Okay, because now the value has increased. If it is greater than 0, we can say formed chars minus minus, we reduce the overall length. Okay, so in this case we have found our solution. We updated our min length, min left, min right. Now we removed one character from the right, that was a. Okay, and this is our new solution. So we reduced the formed character length as well. So now it has reached 3. So it was matching the required character length. Now it has reduced. Okay, now imagine if there was one more a, it will not reach 0, it will still be bigger than 0, it will still be 1, and this window would still be covering. Just as a quick example, imagine if the given this window that we are considering looked something like this. We had a, okay, and this was our solution, because we found a, then we found b, then we found c. If we removed one a from the left side in this solution, this still forms our required solution, D, A, O, B, E, C. So we can check if the character count of window for this left is still greater than 0. That means we have one of the frequency, we have one of the characters available in our window, right? So we'll not reduce the formed characters length. This is still a solution. But since there was only one a, removing the frequency of this one reduce the frequency to 0. So we'll remove and we'll decrement the formed characters. So once we have removed a, we'll move our pointer further. So we'll move our left pointer, or let's say move the left pointer. We can say left plus plus, right? So what we are doing is we are one by one checking the window. Once we found the solution, so formed characters length was equal to the required characters length. We updated our min length, we again checked if it was smaller than our min length, we updated our min length. That part is done. Then we start removing the characters from the left hand side. Okay, and we increment the left hand pointer up and up again, as long as the formed characters is still equal to the required character length. Now in this case, once we remove this character and this is our solution, formed character length is not equal to the required character length, and the loop will break at this point in time. Again we'll go forward, we'll find for new character and we'll check if whenever it happens we'll increase the form character length, and we'll check if the form character length has reached the required character length, and then again we'll start removing. So it will happen when we see an A again. So after this we'll get this window, and now since it's not smaller than our minimum length, we'll not update it, but we'll check the left character D, we'll start updating them, and we'll start removing them from the character length. Now since this will not affect, D will not affect our solution, so it will not decrement our form character length. Form character length will be equal to required character length. Left will keep getting incremented and it will keep getting removing this one. So D will get removed, O will get removed, B will get removed because we have another B. E will get removed and we'll have this as one of the windows, right? Now after removing this, after removing C, this is not a solution, sorry, this is not a solution, right? So again it will go forward, we'll check N, we'll check C, and we will reach this substring. Now we'll check form character length is equal to required character length. Yes, we'll keep updating, we'll keep removing the character from this left side, and at one point we'll reach here, and at this point right minus left is plus 1 is going to be smaller than our minimum length. We'll update the length, we'll remove the characters, so it will be A and C. It will come out of this loop since right side has already reached the end, so the overall loop will end as well. So in the end, whenever our outer loop is ending, we can return our answer. So we can say return min length, that is equal to integer integer dot max value, because we have initialized it with this value. So if it is still the same, that means there was no solution, and we can return empty length, right? So if this is true, we'll return empty, otherwise we'll return s dot, now we want to form substring, s dot substring min left and min right? That's why we have kept min right as right plus 1, because when we are forming a substring, the rightmost index is not picked up. So let's say if I'm sure everyone is already aware of it. So if we are passing the right character is B, so B will not get picked up. We have to pass till this length, so this will get picked up. Okay, so that's all from today's video. Oh, I'm sorry, not today's video. Let's run it. I am still hoping not to get any I got some integer typo, integer, run again. We have some more min length, length. I should start typing a little better, length. Okay, run again. Cannot be converted to boolean. Okay, why are we getting this? What are we returning? We have to return string. Okay, what are we getting? Min length, return min length integer dot max value. We are checking, then we are returning blank string, otherwise we are returning substring. Where is the issue? Return integer dot max value, substring min length, return min length. String cannot be converted to int. Where are we converting this to int? We are returning the string only. Or have I written it inside somewhere else? Let's reduce this. For character, the code looks fine. We're doing a return operation in the end. String cannot be converted to int. Somewhere I'm missing something. It looks like a small typo somewhere. Int cannot be converted to boolean integer. Okay. Oops, my mistake. It's a comparison. Yeah, return min length. We compare the min length if it is still the same, otherwise we return. So if it is still at the max value, we return blank string, otherwise we return the solution. Let's submit. Okay, great. So it's an efficient solution as well. We did take the most efficient approach anyway, so great. So that's all from today's video, everyone. And yes, the overall time complexity is going to be O of m plus n because we are traversing both the strings. So that's all from today's video. For anything, please let me know in the comment section. In the end, please like, share and subscribe. Thank you.